Welcome to the presentation. Today's topic of discussion is numerical problems on arches. In part 1, we have discussed what is an arch, components of an arch, and some of the basic terms and terminologies involved in arches. Along with that, we solved one simple problem. In this particular session, I would like to brief out all the things which we have discussed in part 1, and then I will proceed with the numerical problems on arches. I, Dr. Sangeeta DM, Associate Professor, Department of Civil Engineering, AJ IET, Mangalore, hereby presenting you the session. So, this is the components of an arch which were discussed in the previous session. So, span, the distance between the two springs, two end supports is called as span, and the height, the crown peak point is called as crown point, and that is a riser. The horizontal forces will develop in an arch, due to which the normal thrust, radial shear and bending moment will also have its own effect. Due to the static loads, the forces in an arch are evaluated. The support reactions are evaluated using equilibrium equations sigma V0, sigma H0, sigma MA or MB0. Along with that, if there is a spring at the crown point, then we will have another equation, that is sigma MC is equal to 0. Once you find out the support reactions, then the normal thrust and radial shear at any point of the arch can be evaluated by resolving the components. So, the normal thrust and radial shear can be obtained using the equation n is equal to V sin theta plus H cos theta, and Q is equal to V sin theta minus H cos theta. V is the vertical shear at that point. So, V is the vertical shear at that point. So, this is one simple problem which we solved in the previous session, that is an arch which is of span 40 meter, UDL in the first half span and a point load at the central portion of the right half span. So, initially we solved using moment equation sigma MB is equal to 0, taking moment about point B, VA into 40 minus 20 into 20 into 30 and 100 into 10. See here, W into L into L by 2 and 100 into 10, we calculated support reaction VA. Then using equilibrium equation sigma V is equal to 0, found out VB. Since C is a hinge, taking moment about C, since C is a central point, either you can consider left half or right half. So, I am considering towards the right end, that is towards the support B. One is VB into 20 minus 100 into 10, that is due to the vertical loading, and there will be horizontal force H into height. So, how we can find out the horizontal force? So, once the support reactions are evaluated, next you have to find the radius of the curve R. That can be evaluated using the relation L by 2 into L by 2 is equal to H into 2R minus H. L is 40 by 2 into 40 by 2, and R is, you have to find out the factor R, and H is 8, height of the crown point. That is, so after solving the equation you will get R is 29 meters. So, finding with the using the term R here, you can find out what is theta. Theta is sin theta is equal to opposite by hypotenuse. Opposite is the distance, D to C is 10 meter. The point D is at a distance of 10 meter. So, D to C is either 10 meter, and what is R is 29. So, you can find out what is theta. Theta is sin inverse of 10 by R. Next, you have to find the vertical shear at D. So, vertical shear at D, so one is support reaction VA minus whatever the load is coming before to D, before to the point D. So, VA minus 20 into 10, that forms the vertical shear at D. Using vertical shear and horizontal force you already evaluated, theta you know, you can find the normal thrust and radial shear. These are the things which we discussed in the previous session. With this background, we will proceed with the today's problem. One more example we will take, one or two more problems, and along with the supports at different levels we will solve. This is the problem. A circular arch of span 25 meter with a central rise of 5 meter is hinged at the crown and springing. So, again here it is a 3 hinged arch. It carries a point load of 100 kilonewton at 6 meter from the left support. Calculate the reactions at the support, reaction at the crown point, moment at 5 meter from the left support. So, let me show the figure like this. This forms the figure. There is an arch. The span is 25 meter and the crown is at the center. So, 12.5, 12.5, and there is a point load 100 kilonewton at a distance 6 meter from the left support. That is what written clearly. The crown is 5 meter height. So, first to start with, we will evaluate the support reactions. To start the support reactions, take sigma m B is equal to 0, moment about B is equal to 0, exactly similar to the one which we just solved. V A into 25 minus 100 into 12.5 minus 25 minus 5. So, it is 25 minus 6. One is making clockwise and the other one anti-clockwise. If you take it to the other side, it becomes plus. So, V A is 76 and V B is V A plus V B is equal to 100. So, 100 minus 76 is 24. Since there is a hinge at point C, take sigma m C is equal to 0. So, m C is equal to 0. Either you can consider the left side or right side. If you consider towards support B, there are no any external loads, only thing is H and V. So, with those two things you can solve the, but when you consider the support A side, you have one vertical, one horizontal and the external loading. So, you can go for support B side. V A into 12.5 minus H into 5 is equal to 0. If you solve that, see here, if you can solve that, H is 60 kilonewton. So, support reaction, the first part of the solution is done with. Next, the reactions at the crown point. Next step is you have to evaluate the reactions at the crown point, that is H. What is the horizontal force? Horizontal force, it remains same throughout the span, whether it is at A or B or at C, H remains 60. So, crown also H is 60, because at crown sigma H is 0, it should be in equilibrium. So, H is 60. What is V C? That is at the crown point, V A minus loading or V B. If you consider the left side, V A minus 100, because vertical shear is support reaction minus the previous load, whatever the load is coming before to that zone, minus 100. If you consider for the right side, V B. If you solve for that, you will end V C as 24 kilonewton, and it becomes negative because it is downward. Next, the third part of the question is moment at 5 meter from the left support. So, you have to find the moment. So, in order to find the moment at 5 meter from the left support, you have to find what is R. In order to find out what is R is as usual the equation L by 2 H into 2R minus H. So, H is 5, H is 5. So, what is R? You have to calculate R sin theta. So, see the figure here, H is 5 meter, vertical distance is 5 meter, and you have to find what is R. You have to find out R, you have found out. Next, theta you have to calculate. So, in order to find out theta, in order to evaluate theta, as usual you have to go R sin theta is equal to sin theta is equal to d to c distance divided by R. So, theta you can evaluate. So, R sin theta is equal to 12.5 minus 5, that is the distance 7.5, and sin theta, the same concept you have used. You can form a triangle, drop a perpendicular, and you can evaluate theta. So, theta found to be 24.43 degrees. Next is what is YD distance. What is this YD? YD is the vertical distance of the D. Horizontal X distance is 5 meter, vertical Y distance is we have to find out. So, in the previous session we have resolved the components, and YD is equal to H minus R into 1 minus cos theta. So, you know H, you know R, you know theta, substitute and find out what is YD. Then moment about D is find the forces VA into phi minus HD into YD, because at point D there is no load is coming out. You can consider left side or right side of the D. So, I prefer to consider the left side, and in the left portion there is no loading coming here. Loading comes only in the right portion. If you want to consider the right portion, loading, hinge reaction at C and support loads at support reactions at B, all 5 components has to be considered. For the simplest one, I am considering towards the support A. Only 2 things are coming up. One is 76 into phi and 60 into YD, horizontal force, vertical distance. Depending upon whether it is clockwise or anti-clockwise, you have formulated the equation and solved. That forms the moment at point D. Is it clear? So, let us move back to the problem once again. For the arch, using the equilibrium equations, we have solved and found the support reactions and horizontal force. Next, the second point is at the crown point, what is the force it is asked. So, horizontal force, it remains throughout the arch same. Means the supports are, if the supports are at same level, then the horizontal force remains equal, whether it is at A, B or C, it remains same. Whereas at C, the normal thrust is evaluated. How to evaluate the normal thrust? Or normal thrust, it is or vertical shear. How to evaluate the vertical shear? It is before to that point, what are the loads coming? You have to deduct it. Vertical loads, one is support reaction VA and minus 100. If you consider the left side, if you consider the right side, whatever VB is there, the same thing. So, that is the shear. And the third part is what is the moment. In order to find the moment, you have to evaluate R and theta, that is using the same concept which was discussed in the previous problem. When R and theta are known, you have to find out what is the Y ordinate, Y distance, YD is equal to H minus R into 1 minus cos theta, and then find moment about D. Now, the same problem which is solved in a derivation B. Show that parabolic shape is a funicular shape for a 3-hinged arch subjected to UDL over its entire span. Let the span of the arch be L, rise be H as shown in the figure below. Due to the symmetry, the load is symmetric towards both the sides. So, VA and VB, either you can do sigma MA and MB is 0, that also you can do out, or if since the load is equal, you can directly divide it into two equal portions, so that you will get the support reactions. VA and VB is equal to half of the total load. Total load is W per unit length. So, W into L. So, it is WL by 2. VA is WL by 2, VB is WL by 2. Next, taking moment about C, what is H you are going to evaluate. So, this is a 3-hinged parabolic arch. So, taking moment about C, WL by 2 into L by 2, H into small h, minus UDL is there, W into L by 2 into L by 4. Solving that, you will get H is WL square by 8. Or at any section distance x from A, at any section distance x from A, there is a small point where A is taken in the arch. See here x and y ordinates. So, at that point if you evaluate, moment is equal to VA into x minus h into y minus WL square by 2. But in a parabolic arch, y is given by 4 hx into L minus x by L square. In a parabolic arch, whenever arch is parabolic in nature, y is equal to 4 hx into L minus x by L square. Therefore, moment is given by VA into X. VA is WL by 2 into X minus H is WL square by 8. Substitute all the terms Y and WL square by 2, and this forms equals to 0. Thus, whenever in a circular arch, whenever for a parabolic arch subjected to uniformly distributed load over its entire span, the bending moment at a section is 0. Hence, the parabolic arch is funicular in shape for a 3-hinged arch subjected to UDL over the entire span. Whenever it is UDL and throughout the span, for a parabolic arch it is funicular in shape and the moment is 0. The method of solving remains exactly the same way. With this background, for a parabolic arch with the 3-hinged arches with the supports at same level, we have discussed several problems till now. Now, I would like to take an example of supports at different levels. I would like to take a problem with supports at different levels. So, you can see in the problem, there is a 3-hinged parabolic arch having supports at different levels shown in the figure below, carries UDL of intensity 30 kilonewton per meter over the left half portion. Determine the horizontal thrust developed, H you have to find out. Find also the bending moment, normal thrust and radial shear force developed at section 15 meter from the left support. So, at 15 meter from the left support, what is the bending moment, normal thrust and radial shear you are going to evaluate. The procedure is exactly similar, only thing the crown point is not fixed and you have to fix it. So, taking C as origin, the equation of the parabola is given as. So, as of now, we do not know where the C is. So, distance between the two supports is 40 meters. Distance between the two supports is 40 meter, and as of now we do not know what is L1 and L2. So, what you can do is taking C as the origin, C is the crown point, peak point. So, the equation of a parabola is x square by y is equal to a. Let the horizontal distance between A and C is L1 and C and D be L2. So, L1 square by y is equal to a constant term L2 square by 3. What is this 5 and 3? Heights, height to the crown point, the ratio of length to the height to the crown point. So, L1 square by 5 is equal to L2 square by 3. Solving the two equations, you can end up with a relation where L1 and L2 you will get is equal to L. L is, you know, it is 40. So, L1 is 22.54 meters and 40 minus 22.54 you will end up with L2 is 17.46 meter. So, with this, so directly they will be giving just the span. So, L1 and L2 you have to find out based on the proportion of the height. So, in a parabolic curve, the ratio you have to find out is x square by y is constant. So, using that relation you can find out what is L1 and L2. Next, take moment about C point. Take moment about C point. Where is C point? Moment about crown. Either you can consider left side or right side. Since left side there is a loading, I would prefer to go for right side. VB into L2, H into 3. VB into L2 is clockwise minus H into 3 is making anti-clockwise. Solving the equation you will get H is equal to 5.82 VB. And what is VB? Sigma MA is equal to 0. If you do, you will get what is VB. If you do sigma MA is equal to 0, VB into 40 plus H into 2 is equal to, solving the equation you will get what is VB. Substitute the H value here in terms of VB and you can solve it. You will get what is VB and you can find out what is H, and then you can go for sigma V is equal to 0. So, you can find out VA as well. So, these are the steps which is shown here for solving VB, H and VA. The portion left of C may be treated as a parabola of span. Portion left of C may be treated as a parabola of span. L dash is equal to 2 into 22.54. The portion left of C may be treated as a parabola of span. So, here at x is equal to 15 meter, it is asked to find the moment, normal thrust and radial shear. So, x falls in the left, that 15 meter falls in the left half portion of the arch, So, this is treated as a parabolic arch. You can neglect that side, and this part is treated as a parabolic arch. For that portion, you are going to do the analysis. So, in order to do that, what is the distance of L1? L1 is 22 point. So, here L1 is 22.54. Consider it as a complete arch, just for an assumption, or treat it as a complete full length arch. Therefore, L dash is taken as 2 times of 22.54. Using the equation of parabola, find out what is y. Y is equal to 4 into h into x into L dash minus x, because we just want the ordinate. So, in order to evaluate the ordinate, it is treated as a complete arch, and that equation you are using just to find out what is y. So, at a distance of 5 meter, so h is 5, x is substitute for x is equal to 15, and you will end up with y is equal to 4.44 meter. So, h is 5 meter is the ground distance, and length is, just you are going to treat it as a complete parabola in order to evaluate what is y. So, once you know y, you can find out the moment at a section, which you did exactly similar to the symmetric circular arch, 3-hinged arch in the previous problem. So, taking moment about the section. So, here what are the forces that is coming? If you are taking moment about D, I will consider the left side, that is V A into 15, H into what is the y you calculated, and the load is there, W into L by 2, 30 into 15 into 15 by 2. Is it the same thing that you can see here? Yes. V A into 15 minus H into 4.44 minus 30 into 15 into 15 by 2. Solve this, you will get the moment at the section. Now, at the same point, you are supposed to evaluate the radial, normal thrust and radial shear. To find the normal thrust and radial shear, you have to find what is theta. So, dy by dx tan theta is also given by the relation 4h into L dash minus 2x divided by L dash square. These are the equations which we discussed in part 1 in the introductory slides. So, you can go back to those slides and you can recollect the derivations. Using the relation, you are finding what is theta. Once you know theta, you have to find what is V at that point, vertical shear at that point. So, vertical shear is V A minus loading before point D. V A is 528.62 minus loading is 30 into 15. So, V is what is vertical shear at that point. Then normal thrust is V sin theta plus H cos theta. Q is V cos theta minus H sin theta. Substitute with the terms, theta will be known. So, with that you have evaluated bending moment, normal thrust and radial shear at point D at a distance 15 meter from the left support. This is how the step started. So, L is 40 meter it is given. You do not know what is L1 and L2. So, how you can do? Using the parabolic relation, you have an equation x square by y is constant. So, y they are given for two different sides. If the supports are at different level, y it is given. So, x square is L1 square divided by 5 is equal to L2 square by 3. Solving the relation, you will get what is L1 and what is L2. Take moment about the crown point, you will get an equation between H and VB. Take moment about A, you will get again a relation between VB and H. Solving the things, you can find out what is VB, what is H, then use sigma V is equal to 0, you can get what is VA. So, right now you know what is VA, what is VB, what is H, all the forces are found out. Next, you have to find moment about a section at 15 meter. So, for that, consider the left half portion as a complete parabola. For that, L1 is 22.054 multiplied by 2. So, it becomes a symmetric parabolic curve. It is just an assumption for in order to evaluate the height H at point D. So, find out what is y. What is y at a distance of 15 meter using the relation y is equal to 4hx into L dash minus x divided by L dash square. So, what is y at a distance of x is equal to 15 meter? You can find out using the relation. H is 5 meter, x is 15, L is 45.08. Because this equation is valid only for a complete parabolic arch, but our arch is not complete symmetric parabolic, it is unsymmetric, it is one half side the other way and the other half other way. So, in order we just want that ordinate. So, in order to find the distance, we are just treating it as a complete, no loads are considered for this part of calculation. Next, when moment at this section, so we are considering only the left half side, which is found to be the in equilibrium, then VA into phi, H and the loading, vertical force, support reaction, horizontal force and the loading. Then using the similar reaction, you are going to find out theta, vertical shear, normal thrust and radial shear. So, here is a problem for your practice. Here is a problem for this practice. So, solve this problem and submit the solved one in the Google Classroom, which will be shared as a quiz for you in the tomorrow's session. So, solve this problem for the practice, which is the based on the concept which are discussed in this presentation. Thank you.